math morning or math afternoon, math night. I don't know when you're watching this. I don't know. Do I know? No, I don't know. Anyway, welcome to solving equations with variables on both sides. So this one is the crown jewel of solving equations. You can see down here I made this equation. We've got cat with glasses plus 5 equals 2 times cat with glasses plus 10. What does the cat with glasses equal? I don't know, but we'll find out. Alright, let's go. So in the last lesson, we only had variables on one side of the equation. In this lesson, I'm going to show you how to do it when variables are on both sides. So here are the steps that you want to follow in order to solve equations with variables on both sides. Step number 1, use the distributive property. Right, I'm highlighting that for you. So if you see the distributive property, you can do that first. And when you do this, this will remove any of the grouping symbols. So you might see parentheses or absolute value bars. You could do that first to remove the grouping symbols, and you'll probably use the distributive property. After that, you will simplify the expression on each side of the equation. So we want to simplify. And what that means, it can mean different things, but normally you want to combine like terms. Besides that, you might reduce fractions, simplify decimals, things like that. So when we simplify, the main thing is combine like terms, but you often have to multiply some things, simplify fractions, so on and so forth. The next step is using properties of equality to collect variable terms on one side and constant terms on the other side of the equation. So the properties of equality, that means if you multiply one side times 5, you need to multiply the other side times 5. If you subtract 5 from one side, you need to subtract 5 from the other side. And when you're done doing that, you should have all the variables, so those are the letters like x, z, n, on one side, and the number should be the constant terms on the other side. After that, use the properties of equality to solve for the variable. So that's when you have x equals, 2y, and then you want to divide by 2. And then we're going to check the solution at the end. Do you have to do this every time? No. I'll give you the answers. If you're taking a mastery check or a mastery quiz, then you really want to check your answers. Alright, let's jump into an example. So the first thing we want to do, and we can look back at the steps. Let me go back over there. Use the distributive property to remove any grouping symbols. Okay, in this one we don't have any. The next step, simplify the expression on each side of the equation, combine like terms. Alright, on the same side, do we have any like terms? No. Right, this is a 2x and that's a minus 4. That's a 12x and minus 14. So there are no like terms on the same side. The third one, use properties of equality to collect variable terms on one side of the equation and constant terms on the other side of the equation. So let's do that. So I'm going to highlight 2x and 12x. Those are the variables. So I want to put those on the same side of the equation. And then minus 4 and minus 14, those are the constant terms. I want to put those on the other side of the equation. Alright, so when I do this, I draw a line down the middle to keep everything separate. And now I want to combine this 2x and the 12x. So you could do either way. You could do minus 12x or minus 2. I think it's easier to do the smaller term. So I'll do minus 2x on this side, and then I do minus 2x on that side. Now I'm going to simplify. So 2x minus 2x, that cancels. So I bring down this minus 4. And this equals, now I need to do the other side. 12x minus 2x, that is 10x. And then I have minus 14. So now I have the variable on one side, but I need to move this constant term over to the other side. So to do that, I will do a plus 14 and a plus 14. So it was subtraction, so I do addition, those cancel, and now I need to add what we have over here. Minus 4 plus 14, that equals positive 10, and that equals 10x. So now I have this constant term on the left side and this variable term on the right side. Now I just have to use property of equality to get x by itself. So this is 10 times x. If I divide by 10, those cancel. If I divide this by 10, 10 divided by 10 is 1, and that equals x over here. So my answer is x equals 1. You can go back and formally check this. I'm going to try to do this one in my head. So if I put in 1 for x right there, 2 times 1 is 2. 2 minus 4, that's negative 2. On this side, if I plug in 1, 12 times 1 is just 12. 12 minus 14, that equals negative 2. So it's the same, checked, good. And do you need to do this on every problem? No, I'll give you the answers for the packet, but you should definitely be doing this on a mastery check to see if you got it right. All right, let's go on to this next one. I'll draw a squiggly line. So the first step, if I go back, it says use the distributive property to remove any grouping symbols. Let me do that. So over here I have parentheses, so I'll do 2 times x. That's 2x. And then 2 times minus 4. So remember it's a negative here, so that's minus 2 times 4 is 8. And this equals minus 2x minus 10. And let me draw this line down the middle so I keep everything in the right place. So now I want to get the variable term on one side and the constant term on the other side. So you have two options to start. I can take this 2x and bring it to the right side, or I can take this negative 2x and bring it to the left side. I'm a fan of positive numbers, so if I do a plus 2x over here and a plus 2x over here, this will be a 4x and this will cancel. If I did it the other way, a minus 2x and then a minus 2x, this would be a negative 4. So I like positive numbers, but you can do either one. So we read this like a book from left to right. So 2x plus 2x, that's 4x. I bring down the minus 8. This equals minus 2x plus 2x, that cancels, and then minus 10. Now I want to take the negative 8 and move it to the right side so that all the constant terms are in the same place. So I'll do a plus 8 there and a plus 8 here and draw a line. Over here, this 4x, that comes down. Minus 8 plus 8, that cancels. Negative 10 plus 8, that equals negative 2. The last thing I want to do is isolate the x. So if I divide by 4, because this is 4 times x, the opposite is divide, that cancels, and I divide this by 4. So my answer will be x, I'll draw another line, equals negative 2 over 4. Some of you might be thinking, oh, Mr. Durkis, that's a fraction. I don't like fractions. That's okay. You're going to see fractions for answers, so we might as well do one in the video. This can simplify to negative 1/2, right? So 2 can be divided by 2, and so can 4. Simplifies to 1/2. If you want, you could plug it back in and check, or you can trust me that it works.
Sich mit ihm zu beschäftigen. Jetzt geht wieder ab. Was macht Jason Williams? Oh, was für ein Pass auf Ralph LaFrance. Jetzt spielt sich in die Herzen der Fans hier. Jason Williams, ja. Ist jetzt hier der Liebling aller. Williams von den Sacramento Kings. Ja, was die spektakuläre Spielweise betrifft, ist er uneingeschränkt die Nummer 1 hier. Da, zack. Schön auf den Ellbogen geklickt.
So why did I show you that video? Because it's a beautiful pass. And I tried that the other day in my house, and it was ugly. it was real ugly. So I want to show you an ugly problem. And here it is. So I want you to copy this down. Pause the video if you have to. I'm going to get started right now. So the first step we want to do is, let's find out. I go back. Use the distributive property to remove any grouping symbols. Alright. I see parentheses here and here. So I'm going to do the distributive property to simplify that. Over here, I'm just going to copy this. I know some of you might be thinking, well, I can just do subtraction over here. Well, you can, but I'm going to do one step at a time. So, distributive property, negative 10 times 2, negative 20. Then I do negative 10 times negative 5, and negative times a negative is a positive. 10 times 5 is 50, and then I have this n. Over here, negative times n becomes negative n. Negative times negative 1, negative times negative, is plus 1. So now that I distributed, I can combine like terms on each side. So we have 80n minus 30n, so they are both n, and I can just subtract the numbers. 80 minus 30, that is 50n. And that equals, so over here I have 50n minus n. So 50, this is really 1n. 50 minus 1 is 49n. And then I have negative 20 plus 1. So negative 20 plus 1, that becomes negative 19. So I distributed, then I simplified. That was step 2. Now I want to get the variable on one side and the numbers, the constant terms on the other side. So I have 50n over here, 49n over here. I'm going to move the n's to the left side. So I'll do a minus 49n here and a minus 49n over here. Well, let's see what happens. So 50 minus 49, that is 1. That's the same as just n, right? 1n, or you can just write n. And that equals, well, these cancel out, so I'm left with negative 19. So there's my answer. N equals negative 19. I guess that wasn't so ugly after all. If you want, you can take this, plug it back in and check. I'm going to move on to the next one. Alright, this next one. 4, and then we have the quantity n plus 0.5. Ah! Decimal! Ah! Don't worry, we got it. That equals 5 times the quantity of 2n minus 2. So we start with distribute. 4 times n, that's 4n. And then 4 times 0.5, you can put that in a calculator. Let me do it over here for you though. 4 times 0.5, 4 times 5, that's 20. When you have one decimal, right, or one number to the right of the decimal, so see, like just like that. I start over here, I go this way, put the decimal right there. So that's just 2. So 4n plus 2 equals, I'll distribute this side, 5 times 2n equals 10n. 5 times negative 2 minus 10. Alright, so I distributed. Now I want to get the variables on one side and the constant terms on the other side. Alright, so I can bring this 4n to the right side, or I can take the 10n to the left side. I like to keep my numbers positive, so I'm going to take, well, first, before I do anything, I'm going to draw a line down here. I'm going to take this minus 4n and bring it to this side, minus 4n. Why am I going to do that? You'll see. So 4n minus 4n cancels. I'm left with plus 2. I don't even need that plus 2. Just 2 equals 10n minus 4n is 6n, and we have this minus 10. If I did it the other way, I would have to do minus 10n, 4n minus 10n. That would give me negative 6. I don't like negative numbers, so I'll do it like this. Now I'm going to take the constant term, this 10, bring it over to the left side. So it's a minus 10. I need to do the opposite, which is plus 10. and I do plus 10 on this side. So 2 plus 10 is 12. That equals 6n. And then these ones cancel. Now I need to get the n by itself, so I'm going to divide by 6. Why am I dividing by 6, you ask? Because this is 6 multiplied by n. Alright, 6 divided by 6, bam, gone. 12 divided by 6, this is 2 equals n. Normally you see the variable first, n equals 2, but you can write it just like this. That's good that way. So 2 equals n, got it, great, move on. Alright, things are going to get a little weird right now, so prepare yourself. So we have two things. When a number is a solution, when every number, this is important, every number is a solution of the equation is called an identity. These can be found when both sides of the equation equal each other. If no number exists If no number exists that is a solution of the equation, we say that the equation has no solution. These can be found when all of the variables cancel on both sides and only two different numbers are left set equal to each other. So identities, once you're done solving, you'll have two numbers that equal each other. It might say 10 equals 10, 5 equals 5, 1 equals 1. If you have no solution, you'll have 5 equals 9, negative 2 equals 11, things that are really not equal. All right, so identity. Let me do this example. It might make more sense. So I'm going to go ahead and solve this equation. So first we do the distributive property. 2 times 2x, that's 4x. 2 times minus 4 is minus 8. And then we have this plus 16. That equals 4 times x is 4x. 4 times 2 is 8. All right, now I can simplify over here. So 4x, negative 8 plus 16 is just plus 8. That equals the same thing over here, 4x plus 8. And then I want to get the variables by themselves, so I can subtract this 4x from the right side and the 4x from the left side. This is where it gets weird, right? This side cancels, so I'm left with just 8. But also this side, it cancels as well. So I'm left with just 8. So over here it says 8 equals 8. So that's what the definition said. If you solve it and you have both sides of the equation equal each other, right? So something like that, that's what we call an identity. You can write that down, identity. That means any number that I plug in for x will work. All right, I want you to choose a number. Let's see if it's the same number that I choose. I chose 2. Did you choose 2? If you did, that was crazy. If not, it's okay. So I'm going to plug in 2 here, and I'll just do it talking out loud. So if I put in a 2 for this x, I need to solve the parentheses first. 2 times 2 is 4. 4 minus 4 is 0. 2 times 0 is 0. So this side is just 16. If I put in the 2 over here, 2 plus 2 is 4. 4 times 4 is 16. So 16 equals 16. The number 2 worked. I could put in any number in here, and you can try them if you want. You could put in 0, 100, negative 1,000,000, 5.279, whatever you want, and it will work. All right, so no solution. This is kind of the opposite of that. There is no number that will work when I solve this one. Okay, let me draw a squiggly line and solve it. So if I combine these like terms on this side, negative 15 plus, or negative 15y plus 7y, that becomes 8y. And I have plus 1 equals 3 minus 8y. To get the variables on one side, I don't like this negative, so I'll do a plus 8y. I'll draw my line. And I'll do a plus 8 y over here. All right. Oh, I made a mistake. Where is my mistake? Do you guys know? When I did negative 15y plus 7y, I said that's positive 8. It should really be negative 8. Negative 8. This negative 15, right? This number is more negative than this, so it should be negative 8. So those cancel, and I'm left with 3. These cancel, and I'm left with 1. So I have 1 equals 3. So at the bottom of this, you should write no solution. No solution, that's when, if you have one solution, that means you can put a number in and it makes this equal. If you look at this, right, what number can you put in that you multiply by negative 8, and the same thing over here, right? That's going to be equal on both sides. But then you have a 1 and a 3, right? So something that you multiply by negative 8 and negative 8 is the same, is never going to make these two equal. So if you have an identity, you write identity. If you have no solution, you write no solution. If you look back at these other ones, I did not write identity, I did not write no solution, because those all have one solution. So if you get something that looks like these, that's when you write identity and no solution. Alright, so I just did all those ones. I want you to pause this video and try these ones by yourself. Alright, we're back. Did you do these? I hope you did. Perfect. So let's do this one. First, over here, I would distribute. 10 times 1 is 10. 10 times 4m is plus 40m. Over here, 4 times 3 is 12. 4 times 10m is plus 40m. I'm already looking at this. 10 plus 40m, 12 plus 40m. I'm noticing that they both have a 40m, but then this is 10 and that's 12, so it's a little bit different. Alright, let me draw the line. I'll do minus 40m, minus 40m. Draw another line. Those cancel. I'm left with 10 over here. Bring down to 12. Those cancel. So I'm left with 10 equals 12. So this means no solution. No solution. That makes me sad. Sad face. Alright, let's do the next one. So I'll distribute first. 4 times x, 4x. 4 times negative 3, negative 12. That equals negative 2 times 6. Negative 12, negative 2 times negative 2x. That will be a plus 4x. Ooh, I'm looking over here, right? I got 4x and a minus 12. A minus 12 and a 4x. Interesting stuff. So let me do minus 4x over here and a minus 4x over here. Draw the line, cancels. I'm left with minus 12 equals, bring down that minus 12. Those cancel. So negative 12 equals negative 12. This is an identity. Identities, those make me happy. I'll draw a happy face. Alright, so good luck with the worksheet. This was a tough one, right? We had a lot of stuff going on. So I'm going to show you something that is also tough. And that would be if you challenge a bear to a hot dog eating contest. Darkus, out.
Bear eats the first hot dog. And it is underway. There we go. And there's Kobayashi using his technique. He breaks them in half and he puts as many as he can as well. The bear is going forward as well. Look at that, Mike.
No hands for the bear.
Kobayashi. Look at him staring at the bear. Look at Kobayashi watching his opponent. Now, I wonder if it's the same feeling when he's in a competition with a human being.
Steve, I got to tell you something. When the bear came out, I saw a flash of fear for a second in Kobayashi's eyes because he's never faced a competition like this. It's unbelievable.
See how casual the bear is. Now look at how many hot dogs Kobayashi has left. I don't see how he can beat this bear.
You got to remember, Kobayashi is an eating machine. He's got a formula down where he just goes, never takes a break. He's steady.
Right, and he also, as you can see, Michael, he has the water there because his mouth gets dry and it helps him digest the hot dogs.
Well, Kobayashi is the greatest professional eater in the world. He's got this eating technique down to a science.
It's 1 minute into the competition now. Kobayashi's doing very well. The bear is scooping them up, but obviously it's got a very different approach to eating.
But see, he looks away and he takes a break because he doesn't know it's a competition. He's just a natural eating machine, and he'll take a break, look away, look at the lights, look at our cameramen, while Kobayashi never stops. You can see that dish is going down in front of Kobayashi.
And look how skinny Kobayashi is, and look at the size of the bear.
I was really impressed when Kobayashi first came out. He's in great shape. You can tell he's an athlete. He's got great biceps, and he came out with a small stomach. He won't leave with one, but he's a fabulous-looking athlete.
2 minutes into the competition, Kobayashi is watching that bear like a hawk. That bear is definitely going through the hot dogs, Michael. He's making a strong lead. I can't count.
He's making a dent in that dish.
Yes, he is, and I cannot count them from the angle that I'm at right now, but I would say he is in the lead. It looks like we're going to have a winner very shortly. The bear is now looking at Kobayashi, if you believe that.
Exactly. He's being distracted, and this is what Kobayashi is counting on, but Kobayashi hasn't missed a beat. There's only a few
There
left.
is only maybe 6-7 hot dogs left, and there it goes.
My God.
Oh, my God.
No
There's only
hands.
3 hot dogs left. There's only 3 hot dogs left. Kobayashi has got to be panicking. There's only 2 hot dogs left. There we go.
He's down to the last one.
Kobayashi must know that's it.
This is going to
And
be
that is it. We have a winner. The
It's over.
bear, the beast, has won.